With the impending financial collapse always on the horizon, I thought it might be good to display one of the things that Golang can be really good for, which would be very simple financial planning and financial math. Now, I am not a financial advisor. This is not financial advice, and we're not going to really cover anything super complicated here aside from casting float 32s to float 64s, which is a really annoying thing that I had to do. But basically, we're going to be talking about interest rates, and that is probably the most boring application of a programming language ever. But it does kind of add a little bit of like usefulness to your everyday programming. I use programming for financial planning like literally all the time, almost daily, definitely weekly. I use it to figure out my budget, figure out different possible financial plans for saving up for a house, different things like that. So let's just jump into it. So what we're going to do is compare interest rates. Now, if you're not familiar, if you're not really read up on financial literacy or anything like that, can't blame you. They don't teach us shit in schools and it's dumb. Basically, an interest rate is something that is typically talked about in terms of like an annual interest rate. So you'll see things like APY, which is your annual percent yield. That is going to be the amount of money that you will be guaranteed to make per year according to the average amount of money that you put into your savings account. So if I've got $10,000, or let's just say I put $100 into a savings account that has a 5% APY, after 1 year, I should have $105 if I haven't put anything else into that banking account. Now, things get a little bit more complicated when we start comparing interest rates and when we start talking about whether or not interest rates compound monthly or if they compound yearly. Now, a yearly compounding interest account essentially will say, okay, at the end of this year, we are going to give you X amount of money according to the APY and the average amount of money that you had in that account at any given time for the year. What is more common is an interest rate that is advertised as an annual amount, but it compounds monthly. So if you get a 5% APY, then essentially every month you will make 5% divided by 12 on that account, added to whatever you've got, in that month. So if you've got basically $100 in your account and you've got a 5% interest rate, let's pull up calculator real quick. So you've got $100 and you make 5%, so 0.05 divided by 12 plus 1 times $100. Then you will make 41 cents within that month. Now, the cool thing about monthly compounding interest is you actually end up making a little bit of extra money. We'll actually show that here in a second when we run our program. But essentially what our program is going to do is calculate the difference between two different interest rates based on whether or not they compound monthly or they compound yearly. So let's go up and look at our compare interest function. So we've got our first interest rate, our second interest rate, our starting amount, which is fairly important, and our monthly Boolean, whether or not this is going to compound monthly or not. So we have our ending amounts here. So ending 1 is going to correspond to the case that you've got interest rate 1. Ending 2 is going to correspond to whether or not you've got interest rate 2. So let's take the case of it compounding monthly first, because that is a little bit more complicated. Basically, what we're going to be doing is we're going to calculate the monthly percent yield. So this is going to be your interest rate divided by 100 to convert it into like a real percentage interest rate, and then divide that by 12. And then every single month, you are going to get that times the amount of money that you have in your account in that month, plus the amount of money that you have in your account in that month. So basically, if you've got $100, you're going to do, so let's see, that amount was right here. So 0 point that, nope. Let's just do 0.05 divided by 12. So that is going to give us our monthly interest rate. And we're going to multiply that by 100. That is going to be the amount of interest we get paid for that month, and then we add it to the amount that we have in our account. Now, the next month, we are going to do the exact same thing. So So we're going to do 100.41 times, we're just going to round to 0.41 times 0.00417. And then we're going to do that plus 100.41, and that's how much you're going to have in month 2. And it's going to keep compounding on itself. And if you understand compound interest, to any extent, then you're going to understand why this is better than something that compounds once yearly. So that's what this calculation right here is doing. It is doing that over the course of 12 months. This actually should be less than 12. So I've got a math error there. And then we've got our much simpler case if our interest only compounds once per year. So then we return the absolute value, which means that no matter what order we pass these percentages in, these interest rates in, it doesn't matter what order we pass them in, it's just going to give us the difference. And we're converting that to float 32, doing a lot of other conversions as well. So if we run main.go, we will see the difference between a 5 and a 3.5% interest rate when compounded monthly is $155.95, essentially. The difference between a 5 and a 3.5% interest rate when not compounded monthly is $150. So this is with a starting account value of $10,000. So essentially what this is saying is if you have a monthly compounding interest rate, you're going to make roughly $6 more per year on an initial investment of $10,000. Now, if we up this, then we'll see there's a much bigger difference. We've got $1,559 and $1,499, so roughly that's $60. But the big change happens right here. So let's say we're talking 24 months, less than 24, and right here we need to do ending 1 equals ending 1 times that. So let's do, I think this should be the right math. So let's say we do it over 2 years. Now we've got a huge difference. We've got $3,200 worth of interest versus $1,500 worth of interest. That is fairly major, and that also does not sound quite right, because that would mean the interest rate is the same here. Oh, but that should be right. I might be doing the math wrong here. It's a little late, but essentially I'm trying to display 2 things. 1, compound interest is awesome. 2, you can use Golang and fairly simple code to decide, for example, whether or not you want to go with an account that has a 5% interest rate or a 3.5% interest rate. Now, obviously, you want to chase after the higher interest rate regardless, because that's free money, whether it's $6 or $1,500. It's free money is free money. But this will kind of show you the difference between the two. And I think it took me maybe 10 minutes to write this code, even if it's buggy and ugly. It didn't take long. So Golang can be used for a billion different purposes, writing web APIs like I've talked about on this channel already, or just doing fairly simple financial planning. So if you found this useful, easy to understand anything like that, let me know in the comments section. Take it easy. Peace.